Okay, Assalamualaikum and hi. Today we will learn about permutations and combinations, or in Malay, pilih atur dan gabungan. So let's see first the permutation. Okay, what is permutation of a set of objects? Permutation of a set of objects is any arrangement of those objects in a definite order. Or in other words, order is important. Maksudnya dekat sini pilih atur tu mementingkan susunan. For example, if we have A, which consists of elements A, B, C, and D, then AB is what we call as two-element permutation of A. And ACD is three-element permutation of A. And ADCB or ABCD is four-element permutation of A. Okay. Okay. The order in which objects are arranged is important. In permutation, the order is important. For example, AB and BA are considered different two-element permutation. Even though there are this AB and BA consist of two same element, but the arrangement are different. Susunan dia tu berbeza, walaupun terdiri daripada dua alfabet yang sama. So do as ABC and CBA are different three-element permutation, and ABCD and CBAD are different four-element permutation. Okay. Next, for example, the six permutation of ABC are the six different arrangement of ABC. So we can arrange few different arrangement from this alphabet ABC, which are ABC, ACB, BAC, BCA, CAB, CBA. So altogether we have six arrangements. So how do we know how can we calculate the arrangement? The number of arrangement is here we have 3, right? A, B, C. So we multiply 3 times 2 times 1. The number keep decreasing. 3 times 2 times 1. So you will get all 6 arrangement. Next is the number of permutation. The number of permutation can be calculated using the multiplication principle. So what is multiplication principle? Prinsip darab, okay, multiplication. If there are m ways for an event to occur and n ways for another event to occur, then there are m multiply n ways for the two events to occur. Maksudnya dekat sini, if you have two events, dua kejadian, dan setiap satunya ada number of way untuk berlaku. Satu m ways, the other one is n different ways. So the total, you will need to multiply these two, m multiply with n. Kena darab dua-dua ni. Okay, let's see the example. For the when we're going to use the multiplication principle is in this case. A coin and a dice are tossed together. Duit shilling dan juga dadu kita lambungkan sekali. How many different outcomes are possible? Okay, berapa hasil outcomes yang mungkin kita akan dapat? So the solution, untuk coin, the coin has two possible outcomes, which is head, H, dan juga tail, T over here. And the dice has 6 possible outcomes. So dadu ada 6 lah outcome. So the number of different possible outcome is, since we have two events, kan? Satu, kita lambung coin. The other one, kita lambung the dadu or the dice. So you have two events. So we use the multiplication principle just now. You need to multiply number of ways. So, untuk dadu, kita ada 2 possible outcome, and for the dice, you have 6 possible outcome. So, you just need to multiply these 2 times 6, then you get 12. So, altogether, you have 12 different possible outcomes, which are, okay, so kita buatlah dekat sini table so that you can see it clearly. Satu, kita punya dadu, kita punya dice, ya, sorry. And this one, kita punya coin. It should be dice, okay, not die. Okay, and head and also tail. Okay, 1, 2, 3. For dice, untuk dadu kita ada 6 outcome, and for coin we have 2, which is head and tail. So now you can match it, okay? You can map it like 1 to 1 lah. So head 1, head 2, head 3, head 4, head 5, and head 6. So do the tail. Tail 1, tail 2, tail 3, tail 4, tail 5, up until tail 6. So you can calculate, you can count actually the possible outcome. 1, 2, 3, 4, 5, 6. And for the second row also you have 6 possible outcome, which means altogether you will have 12 possible outcomes. This is how you get the 12 possible outcome when you draw the table. Or otherwise you can use the multiplication principle. Okay, we're still in the permutation of n objects. We will now consider the method for finding a number of permutation on the letter A, B, and C using the multiplication principle. So how many arrangements of the letters A, B, C are there? Let us consider the number of ways of arranging n letter. Okay, if we have one letter, then there will be just one arrangement. Kalau kita ada cuma satu huruf, maksudnya kita cuma akan ada satu susunan sahaja. For example, A. Okay. Then, if we have two letters, then there are two different arrangements. Contohnya, AB and also BA. How about this one? If we have three letters, the different arrangements are, we have A, or B, or C. These are the three ways of choosing the first letter. Ini cara, kita ada tiga cara untuk pilih huruf yang pertama. Sama ada you want to choose A, or you will start with B, or you will choose C. So ada tiga cara untuk huruf pertama. Okay, when the first letter has been chosen, there are two letters from which to choose the second. And the possible ways of choosing the first two letters are like this one. You have the first one, you can choose from these three, A, B, or C. And then the second letter, you can choose the other two. There are two ways of choosing the second letter. Whether you start with A, then the second one you will have to choose from B or C. If you start with B, you will have to choose A and C. If you start with C, then you have an option for A or B for your second letter, meaning that you have two options or two ways of choosing the second letter. Okay. For each of the three ways of choosing the first letter, there are two ways of choosing the second letter. Okay, hence there are three multiply two ways of choosing the first two letters. Having chosen the first two letters, there is only one choice for the third letter. Maksudnya kita dah pilih daripada tiga tu. Untuk first letter, kita dah ada tiga cara. Kita ada tiga option. And then for the second letter, since kita dah pilih satu tadi, yang tinggal cuma dua cara. And for the last letter, yang ketiga, since kita dah pilih dua yang dekat depan, so we'll only have one option left, one way left lah. There is only one possibility for the third letter. Okay, not dekat situ. If repetition are allowed, Kalau pengulangan dibenarkan, we can choose from all 3 digits for each digit of the number. Ataupun we can choose all the 3 alphabets, 3 letters tadi for each digit. Okay, for each letters. A digit can be used more than once. Ataupun letter tadi tu kita boleh guna lebih daripada sekali. That one if repetition are allowed. Kalau pengulangan dibenarkan. Okay, so yang tadi tu we will have like 3 multiply with 2 multiply with 1 ways of arranging the 3 letters of A, B, C and D. So you multiply this one, you will get 3 times 2, 6 times 1. So you will have 6 ways of arranging letter A, B and C. Okay, how about this one? How many different ways of arranging 3-digit numbers from digit 5 and 6? Berapa banyak cara ataupun untuk kita susun 3 digit from letter 5 and 6. Kita ada dua ni saja, 5 and 6, okay? So untuk yang pertama, for the first option, you will have these two, 5 and 6. And then for the second digit, you will have 2 options as well, 5 and 6. And then for the third option also, you will have 5 and 6 as your option. Meaning that there will be 8 different ways, which is from, macam mana kita dapat 8 ni, is from here. Here you have 2 ways, 2 times. This one also you have 2 times 2. And from here, for the third digit as well, you have 2 options or 2 ways. So 2 multiply with 2 multiply with 2. So you will get altogether 8 different ways. Okay, in general, number of permutation of n different objects taken all at a time without repetition. Kalau tanpa pengulangan, maksudnya cara untuk kira number of permutation adalah npn, meaning that n multiply with n minus 1 multiplied with n minus 2 multiply with ... until you get number 1. You can also write it down as n prime, like this one lah. Okay, n prime. So n prime is actually equal to npn. N prime or n factorial, we call it as n factorial, okay? N factorial, sorry, not n prime. N factorial means the products of all the integers from 1 to n inclusive and is called n factorial. N factorial. Okay. So number tu berkurang daripada n, you darabkan dengan n minus 1. And then you multiply again with n minus 2. Dia berkurang, semakin berkurang, minus 1 until you get the last one is multiply with 1. Okay, example 2. In how many ways can 10 instructors be assigned to 10 section of a course in mathematics? So, berapa cara untuk kita susun 10 instructor yang kita assign kepada 10 section dalam mathematics. So, substituting n is 10, we get npn. Maksudnya, 10 ada 10 instructor dan kita hendak susun dia kepada 10 section. So 10 permutation 10, or we can say it equal to 10 factorial. So this one you just key in into your calculator, 10 factorial or 10 permutation 10, you will get this one. Okay, this is the answer. Okay, now we move on to the permutation of R objects taken from n different objects. Okay, so kalau tadi npn, now you have R object. R object yang diambil daripada n different object. Maksudnya n different object, n tu dia dia punya bilangan sebenar, tapi kita cuma ambil sebilangan saja daripada n tu, iaitu r. Okay, the number of permutation of R objects chosen from a set of n different objects is denoted by n permutation R. P, capital letter P over here is denoted permutation, yeah, equal to n factorial over n minus R bracket factorial. So this is the fixed formula behind this one. If just now we have npn, now you have n permutation r, which is n factorial divided by this whole thing. So let's see when we can use the NPR formula. Example 3, how many arrangement of the letter of the word begin are there if number 1, 3 letters are used. Number 2, all of the letters are used. So we have word begin. Begin consists of 5 letters. 1, 2, 3, 4 and 5 letters. So the first one, we need to find how many ways if we only use 3 letters. Cuma guna 3. Out of 5, 5 is your n. We only want to use 3, so R equal to 3. So we can use the formula just now, NPR, which is your n is 5 permutation and your R is 3. Or this one you can straight away key in into the calculator, or you want to show the step using the formula given just now, n factorial meaning 5 factorial divide by n minus r. This is n minus r. Okay. Here is n minus r. Okay. So 5 minus 3 you get 2 factorial. Okay. Or in other words, it can be written down as 5 multiplied with 4 multiplied with 3. Okay. So you can just simply key in this one, 5 permutation 3 in your calculator. So you'll get the answer 6t. And then the arrangement for number 2, you need to find how many arrangement if all of the letters are used. We use all the 5 letters, meaning your n equal to 5 and you need to use all letters, which is also 5. So the number of arrangements if all letters are used is npn. Okay, 5 permutation 5, or we can just write down as 5 factorial or n factorial. This is n factorial. Okay, so you get the answer 120. Okay, how about this one? Permutation with condition. Pilih atur tapi dengan syarat. For example, how many 3-digit numbers can be made from the integers 2, 3, 4, 5, and 6 if each integer is used only once? Dia kata bersyarat dekat situ. Kenapa dia kata bersyarat? Sebab kita ada kita hendak buat 3 numbers, 3 digit daripada 1, 2, 3, 4, 5 numbers ni. But then, dia tetapkan syarat dekat situ dengan syarat setiap daripada nombor ni cuma boleh guna sekali. Only once. Okay. So, we see the second question. There is no restriction. The second condition, dia letakkan tidak ada restriction. Maksudnya, you can use more than one. No restriction means you can repeat the number. Okay, you can use more than once. There is no restriction on the number of times each integer can be used. Okay, solution for the first one. Dia mau buat 3 digit saja numbers, and each digit or each numbers can only be used once. Cuma boleh guna sekali. So n equal to 5. R equal to 3. 3 is because you need to form 3-digit numbers from these 5. Okay, so NPR. You use the formula just now, NPR. So you just key in into calculator, or you want to show the step just like this. So you get 60. So there are 60 different arrangements. Okay, this is from the formula. Yeah? This is actually from the formula n factorial over n minus r factorial. Okay, okay, there are 60 different way. And how about this one? When there is no restriction, meaning you can use the numbers um, repeatedly lah. Repetition is allowed. Okay, meaning from 5 you can choose for the first digit, you have 5 option, and then for the second digit you have 5 option as well, and then for the third digit you have 5 option as well. So you can multiply this one using the multiplication principle, 5 times 5 times 5. So altogether you will have 1 to 5. Example 5. Find the number of arrangements of 4 digits taken from the set 1, 2, 3, 4. In how many ways can these numbers be arranged so that A, the numbers begin with digit 1, and B, the numbers do not begin with digit 1. So we have two options. The first one is the number begin with 1, and the second one, the number do not begin with digit 1. Okay, for the first one, number of arrangement of 4 digits, since we have 4 digits over here, so the number of arrangement will be 4pn, remember? 4pn or 4 factorial, which is 24. There will be 24 arrangements. And A, if the number begin with digit 1, if the arrangement begin with digit 1, then the number of ways the 3 remaining digit can be arranged is 3 factorial. Because the first one is already fixed. You must start with 1. So like yang lagi 3 baki dekat belakang tu, you will have 3 factorial. The remaining 3, yang 3 baki dekat belakang, 3 remaining digits can be arranged in 3 factorial, which is equal to 6. Okay. And for the B, the number do not begin with digit 1. So we first need to obtain the number of arrangement that do not begin with digit 1. So you have the total, which is 24 just now. If 4p4, then you have this one of 4 factorial, you have 24. Okay, since we do not want it to begin with 1, you just need to minus this 24 minus this one, because this one is the one with starting with digit 1. Okay, 24 minus 6. So you will get 16. Okay, and example 6. 4 sisters and 2 brothers are arranged in different ways in a straight line for several photographs to be taken. How many different arrangements are possible if A, there are no restrictions, B, the 2 brothers must be separated. Okay, let's see. For the A, there are no restriction, meaning no restriction. The 2 brothers and the 4 sisters can sit anywhere as they want. Okay, so there are 6 of them, 4 plus 2. So we can make it as 6 factorial or 6p6 or 6 factorial. So you'll have like 6 factorial. We can write it down in this way. 6 multiply with 5, multiply with 4, multiply with 3, multiply with 2, multiply with 1. So the number getting decrease, 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 and minus 1. Each of it minus 1 until you get 1 at the back over here. So you can stop. And this you will get 720. Okay. And then we have for B, the 2 brothers must be separated. Two brothers must be separated, meaning that number of permutation, NOP here is number of permutation, okay? Number of permutation, the two brother must be separated is actually equal to number of permutation for no restriction because this is the total. Okay, no restriction meaning semua pun boleh. So you just need to minus number of permutation brother sit next to each other. Asalnya kita mau cari yang two brothers duduk dipisahkan. Tidak boleh sit next to each other. So what we need to find is the one that with no restriction, you minus with the one sitting next to each other. Okay, kontrakan saja. So if the brothers sit together, consider the two brothers as one unit. Kalau dia duduk sebelah-sebelah, dua brothers ni, dua beradik ni tadi, yang lelaki duduk sebelah-sebelah, kita consider dia sebagai one unit. So there are 5 person to arrange, giving 5. Kenapa 5? Because we have 4 sisters. 4 sisters plus 1 unit of brother, which consists of 2 brothers. Okay. 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 Oh, not the spelling over here mistake. Should be as consists. Okay. Okay. So you have 5 person, giving 5 factorial. But the two brothers can be arranged among themselves in 2 factorial ways. Sebab di antara dua brothers ni sendiri, kita boleh susun dia, the position can be berubah. Mungkin yang abang duduk sebelah kiri, yang adik duduk sebelah kanan. Or vice versa. Okay? Di antara dua beradik yang lelaki tadi pun boleh ada dua susunan. That's why you have 2 factorial lah. Thus, total number of ways brothers sit next to each other is 5 factorial multiply with 2 factorial. So you get 240. Okay. Ini yang sit next to each other, duduk bersebelah. 5 factorial mewakili yang ini tadi. 4 sister plus 1 unit of brother. Tapi jangan lupa 1 unit of brother ni ada 2 orang kan? So dia boleh duduk berubah-ubah di antara dua tu. So we have another 2 factorial over here. That's why you need to multiply this both. Okay, therefore, number of permutation, the two brothers must be separated. Since we already have just now yang no restriction is 720 and we get the one yang ini next to each other. This one is next to each other. So you just minus. Okay, for no number of permutation, for no restriction, minus brothers sit next to each other. So you get 720 minus 240, you get 480. Okay. Okay, example 7. Arrange 6 boys and 3 girls in a straight line so that the girls are separated. In how many ways can this be done? Okay, so dia kata kita ada 6 boys and 3 girls. So total we have 9, kan? Tapi ke-9 ni semuanya duduk dalam straight line. And then the girls are separated, meaning that the girls cannot sit next to each other. So, consider this arrangement ya. Kita consider susunan yang ini. Let the 6B over here, huruf B dekat sini, represent the boys. And the O, small letter O over here is represent the space for the girls. Since we have 3 girls, so boys ni, maksudnya 3 girls ni tadi tidak boleh duduk tiga-tiga tu semua duduk sekali. Dia kena pisah-pisah. So kita boleh letaklah dia either dia dekat sini, or dekat sini, or dekat sini, dekat sini, dekat sini, dekat sini, and dekat sini. As long as dia tidak duduk bersebelah. Okay. So the 6 boy tadi, inilah dia. 6. Ada ruang di antara boys tu, kita boleh selitkan yang girl. One girl, okay? So, number of arrangement for the boys, ada 6 ways untuk kita susun boys tadi. So, 6 factorial. And number of arrangement for the girls. Ada berapa pilihan yang kita ada? 1, 2, 3, 4, 5, 6, 7. We have 7 spaces for the girl. 7 spaces, but then we only have 3 girls. In this case, we only have 3 girls. Yang mana 3 girls ni boleh pilih lah di antara 7 ni. Dia mau duduk dekat mana. So you can write it down this way. 7 permutation 3. Because 7 space available for the 3 girls. We did not use all the 7 spaces. We only pick 3. Okay, out of 7, you only pick 3. 7 permutation 3. So you get 210. Okay. So the total number of arrangement of 6 boys and 3 girls where the girls are separated adalah 6 factorial, yang tadi yang boys, multiply with the girls. The one you get just now, multiply with 210. So the answer is this one. Okay. Example 8. There are 10 students, out of whom 6 are female. Ada 10 pelajar, 6 daripadanya adalah perempuan. How many possible arrangements are there if they are arranged in a row? Maksudnya kalau 10 pelajar tadi, 6 adalah pelajar perempuan, berapa possible susunan yang kita boleh dapat kalau kita susun semuanya dalam satu baris, arrange in a row. Semuanya dalam satu baris. And then for B, males always sit on one side and female on the other side. Meaning lelaki, perempuan duduk asing-asing. Lelaki either dia sebelah semua lelaki. Kalau 10 tadi ada 6 perempuan, maksudnya ada 4 boys, kan? Ada 4 boys. Meaning you have 4 boys over here. You have 4 boys. So total 10. Males always sit on one side and female on the other side. Maksudnya yang males tadi mungkin duduk sebelah kiri, yang female duduk sebelah kanan. Or vice versa. Ataupun terbalik lah. Okay. So first kita cari yang they are arranged in a row. Duduk semua sekali. 10 orang ni duduk semua sekali sebaris. So meaning that there are no restriction. This one. No restriction, yeah. So we just put it as 10 factorial, okay. And then for B, male always sit on one side and female on the other side. So kita ada dua option, sama ada male sebelah kiri or female sebelah kanan. Oops, or female sebelah kanan, yeah. Or atau we can write it down as female sebelah kiri, male sebelah kanan. So this is 2 factorial. We have 2 factorial over here. Okay, that's why you have 2 factorial. Sebab di antara kedudukan male dengan female tu, you boleh susun dua cara. Sama ada macam ni, macam ni. Okay, 2 factorial. And 6 factorial comes from the female. 6 factorial come from the female. Sebab female tu, dalam 6 orang tu, mungkin dia boleh duduk. Orang pertama mungkin duduk di kedudukan ketiga. Orang keempat mungkin duduk di kedudukan kedua. So, dia boleh pindah-pindah antara 6 tempat tadi lah. And sama juga, this one is for female. This one is for male. Okay, this is for male. So, you will have like 4 factorial. Ada 4 pilihan lah di dalam 4 pelajar tadi. So 4 factorial. So you just multiply this one, you will get the answer. Okay, next. Example 9. In how many ways can 4 girls and 5 boys sit in a row if the boys and girl must sit alternate to each other? Maksud dia, kita ada 9 orang, 4 lelaki, 4 perempuan, 5 lelaki. 4 girls, 5 boys. And then you kena cari macam how many ways so that the girl and boys must sit alternate to each other. Alternate meaning berselang-seli. Kalau boys, lepas tu selang lagi girls. Boys, girl, boys, girl, boys, girl. Macam tu lah. Okay, so kita buatlah 5 petak. 5 boys, so you have 5 boys. 1, 2, 3, 4, 5. So in between, you will have 1, 2, 3, and 4. You have 4 spaces for the girls just now lah. So the number of permutation will be 5 factorial times 4 factorial. 5 factorial is come from the boys, the 5 boys just now. And 4 factorial come from the 4 girls. Mungkin yang the first girl duduk sini. Or mungkin the fourth girl duduk dekat sini. The second girl duduk dekat sini. The third girl duduk dekat sini. Or mungkin the other way around lah. Okay, that's why you have 4 factorial. Ada 4 factorial, you tekan calculator, so you get the answer untuk kedudukan girls tadi. So you need to multiply. Guna balik prinsip multiplication principle just now. And for example 10, 4-digit numbers are to be formed from the digit 0, 1, 2, 3 up until 6. So we have 7 digits dekat sini. 7 digits. But then you just out of 7 ni, you just need to create or form 4 digit saja. You kena bentuk 4 digit, 4 nombor daripada 7 nombor yang ini. Without repetition. Dia tetapkan dekat situ, tiada pengulangan. So how many numbers can be formed if each number is less than 500? If less than 5,000. Okay. So berapa banyak nombor yang kita boleh bentukkan kalau nombor tu kurang daripada 5,000 and tidak ada pengulangan. Tidak ada pengulangan maksudnya kosong ni cuma boleh, setiap nombor ni hanya boleh guna sekali sahaja. So, you create a box or space for space. For space because we need to create or we need to form 4-digit numbers, kan? So, for space, 4 blank spaces. And then, since dia dah bagi tahu less than 5,000. Less than 5,000 meaning you cuma boleh pilih start daripada 1, 2, 3 dan 4. The number cannot start with 0, kan? So it should at least start with 1 lah. 1, 2, 3 and 4. Why only up until 4? Sebab the maximum we can get is number 4999. 4,999 cannot reach 5,000 sebab dia kata less than 5,000. Okay. So the number of permutation is for the first space you can put as 4. And then the second space kita dah ambil 4 number kan? So meaning that you dah pick satu nombor dari sini. So yang total ni ada 7, you dah pick satu nombor. Yang tinggal cuma 6. That's why you multiply with 6. 6 number dekat sini lah. Okay. Okay, so you have like 4 numbers dekat sini. And then you put another 6 dekat sini. And then what happen next is you put another 5. Kenapa 5? Sebab you dah pilih 2 nombor. 1, 2. So 7 tolak 2 you get 5. And then they're getting decrease lah. Tolak lagi 1. So you get 4 over here. So dah pilih 3. So the last one cuma ada 4 nombor lagi. Okay, so you will multiply this whole thing. So you get 480 ways. Okay. Sama jugalah untuk yang ini. the number must begin with digit 4 and 6. Okay, dia dah tetapkan 4 and 6, meaning 4 ataupun 6. So you have two ways lah of doing it, whether you start with 4 or you start with 6. So 2 over here. And then in the bracket, we'll have like 1. 1, kenapa 1? Sebab you dah fix, you letak satu nombor dekat sini, which is 4. It's either 4 or 6. So 1 lah. And then since you dah pilih satu nombor daripada 7 nombor yang ini, so yang tinggal cuma 6 nombor lagi. That's why you get 6 over here. Okay? You get 6 over here. And then berkurang lah. Dah pilih 2, lagi tinggal 5 pilihan. Dah pilih 1, 2, 3. Dah pilih 3, lagi tinggal 4 pilihan out of 7. So you just multiply it. Okay. The 2 here is for this one, number 4 and number 6. Yeah. This one. Okay, the last one. The number, the 4-digit number is an odd number. Maksudnya nombor ganjil. Kalau odd number meaning yang dekat belakang dia mesti nombor ganjil lah. So nombor ganjil we start with 1, 3 and 5. You only have 3 option at the back. So kalau tadi kita start filling the first box, now you start with the last box. Sebab dia bagi hint odd number. Macam mana kita tahu nombor tu odd number? Bila digit yang belakang sekali tu bermula dengan nombor ganjil lah. 1, 3 atau 5. So ada 3 option. That's why you have 3. Okay? So and then okay, since dia ada 3 dekat sini, you have like 5 numbers lagi lah dekat depan. 5 numbers dekat depan. So you boleh start lagi dekat depan. 5 numbers. Kenapa I said 5 numbers not 6? Sebab sini dah ambil 1. Mesti you akan fikir, oh ada 6 lagi yang tinggal. Yes, betul ada 6. But we cannot start the numbers with 0, right? We cannot start with 0. So 6 minus 1, you get 5. 5. And then you have lagi 5 numbers. Tadi 6. Tolak 1, dapat 5. So yang 5 ni dia boleh masuk yang 0 tadi. And then berkurang lagi, dah pilih 5 tadi. So sekarang akan jadi tinggal 4. That's how you get it lah. Okay. Okay, next is permutation where some objects are repeated. Dekat sini, pilih atur bila ada satu objects tu yang berulang. Okay, in general, the number of permutation of n objects mean yang keseluruhan, comprising of R1 identical objects. Identical mean yang sama. R2 identical objects up until Rk identical objects is given by this formula. Kalau dia kata kalau you ada satu situation yang mana you have like n factorial, not n factorial. You have n numbers and you ada R1 up until Rk yang mana this R ni dia berulang. So you have this formula lah. N factorial divided by the one yang repeated tadi. R factorial, R2 factorial, until Rk factorial. Let's see example 11. How many different permutations can be made using the letters of the words books, lotto, and mathematics? So if you see over here this word, all these 3 words consist of repeated alphabet. Ada huruf yang berulang. Obviously, in books kita ada double O, and in lotto you have double O and T. In mathematics you have double A, double M, double T, and so on lah. Okay, so let's see how many permutation. So based on this formula just now, the one that have repeated object, you're gonna formula ni n factorial over r factorial multiply with another r factorial yang berulang lah. So for books, we have n. Our n is 5. 1, 2, 3, 4, 5. N is 5. And the one that repeated is only this one. R1 equal to 2. Ada dua benda yang berulang. Okay. So 2. So we use the formula just now. This is the formula. N factorial over R factorial. Because you only have one R dekat sini yang berulang. Satu saja objek yang berulang iaitu O. 5 factorial over 2 factorial. Why 2? Because the O is repeated 2 times. Ada dua kali O. So 2 factorial lah. So you just key in this in calculator. You get 60. So the number of different permutation is 60 for books lah. And for lotto, we have 1, 2, 3, 4, 5. 5 alphabets. So the N is 5. And for the first repeated object is O, kan? 2. O ni berulang sebanyak 2 kali. So 2 over here. The other things yang the other object yang repeated is T. This is for T, ya. Okay, let me something lah. Kejap. This is for O and this is for T. Okay. Tadi untuk O, ini untuk T yang berulang 2 kali. So you use again this formula. 5 factorial over 2 factorial. 2 factorial for the O. And then the other 2 factorial is for the T. Okay. This is for O. This is for T. So you get the answer is 30. Next. Oh, I missed the mathematics punya slides kan. So sama jugalah untuk mathematics. So you have your n 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you have your n equal to 11 for mathematics. So your r equal to r1 equal to 2. This is for m. Ini untuk m. Okay. And then you have R2 equal to 2 juga. Apa lagi yang berulang? This is for A. And then this is 2 ya. You have R3. R3. Okay, what? Okay, we have T over here. For T ya. You have twice. Dia berulang 2 kali. Ada lagi yang berulang M. M ada M, A ada A. And then we have T over here kan. So you have all these things, then you can use the formula just now. 11 factorial over 2 factorial multiply with 2 factorial multiply with again another 2 factorial. So you will get the answer. That one is for mathematics. Let's see example 11. Okay. Example 11, how many different arrangements are there for the letters of the word arrangements? So word arrangements ni sahaja ada berapa? Ada 12 huruf. If A, it begins with R and ends with E. Okay, so dia mula dengan huruf R dan dia berakhir dengan huruf E. Memandangkan we have all together for arrangement. We have 12. We have 12 letters. So yang ni dah satu, yang belakang dah satu. Meaning in between you will have to fill in another 10 letters. 10 letters lah. Okay. So you have number of permutation is untuk R, since they're the fixed, begin with R and with E. R you have 1. multiply with, untuk yang tengah ni you have 10 factorial over 2 factorial multiply with 2 factorial. Okay. So, kenapa 2 factorial multiply with 2 factorial? Sebab dekat sini, A ni ada berulang. And R also berulang. Apa lagi yang berulang? Huruf N. N also berulang. E pun berulang. Okay. So, dekat sini ada 4 benda yang berulang. 4 object. Ni A, N, R dan E. Repeated. Okay. But then kita excuse, kita ignore the R and E over here. The R and E dekat sini kita tak masukkan dalam yang repeated. Kenapa? Sebab dia dah dekat luar adalah letak satu. So yang dekat dalam ni of course dia tidak akan berulang lagi yang dekat dalam ni lah. So yang akan berulang dekat dalam ni cuma huruf A dan huruf N. That's why you have 2 factorial times 2 factorial. And multiply with, again, 1. 1 is for E. Okay. This is for R. And yang this whole thing, semua ni untuk yang tengah-tengah. Dia ada 10 letters. Okay, so you get the answer lah. Ni dah boleh tekan calculator. Okay, then. Yang kedua, dia kata the two letters E are separated. Dia dah letak syarat yang E tadi yang berulang tu kena separate. So, kita ada this formula. Kalau yang separate ke, sit next to each other ke, dia punya pattern lebih kurang sama. So, you have the number of permutation separated. Number of permutation separated is actually equal to without restriction, you minuskan dengan yang E yang together. Dia macam ni lah lebih kurang. Kan? Macam yang tadi, yang boys and girl next to each other. Sama juga in this case. So you have this formula. Yang separated is actually equal to without restriction, meaning without restriction ni yang keseluruhan. Keseluruhan like 2, you have 12 factorial divide by 2 factorial times 2 factorial times. This is the one yang repeated tadi. Untuk ni. Untuk A, N, R dan E. Okay. Ni untuk A, N, R dan juga E. Kat sini. Okay. So this is for without restriction. And kita cari pula yang untuk E duduk sebelah-sebelah. Together. So kalau dia together, meaning we have like macam ni lah susunan dia kan. Kalau E duduk sebelah-sebelah. So this one we consider as 1. 1 unit. Kita consider dia sebagai 1 unit. Plus the other 10. Okay. Okay, so you have like 11 factorial. Sebab tu dapat 11. Sebab dia 1 unit plus another 10. 11 factorial divide by 2 factorial. 2 factorial ni datangnya dari sini. 2 untuk A, 2 untuk N, 2 untuk R. E itu tidak termasuk dah sebab dia dah letak siap-siap dekat depan. So, you have this one, you just key in into your calculator, these two. So, you just minus. Untuk the one number of permutation where the letter E must be separated is actually equal to number of permutation without restriction, yang keseluruhan, minuskan dengan yang E sit next to each other lah, ataupun together, this one. So you will get the answer. And for C, the two letters E and the two letters A are together. So, dia dah bagi tahu siap-siap E dan A are together. So, E ni kita boleh consider as 1 unit, duduk sekali. A ni pun another 1 unit. Kan? So, out of 12 tadi, ni keseluruhan ni adalah 12 kan? N equal to 12. We have 12 You have 12. Okay, 12 minus this one, minus lagi ni 1. Tapi dalam ni ada 4. 1, 2, 3, 4. 12 tolak 4. So, yang tinggal ada 8 huruf lagi. 8 huruf. Tapi this one kita consider sebagai 1 unit. Ni sebagai 1 unit. Bila mana you the words, not words, the alphabet or the digit, the numbers next to each other, kita consider dia sebagai 1 unit. So, macam EE ni 1, AA ni 1 lah. So, you have like 1 plus 1 plus 8. That's why you get 10. Okay. Sebab tu dapat 10. 1 tambah 1 tambah 8. And then divide by 2 factorial. Times 2 factorial. Macam tu. Okay. 2 factorial times 2 factorial ni, ini untuk huruf R. The other one is for huruf N. Because yang E dengan A ni tadi dah tidak consider dah yang repeated. Dia dah letak siap-siap dekat depan. And this one you multiply with 1, multiply again with 1. Okay. Kenapa 1, 1 ni? Ini untuk yang 8 letters, this one. This one is for ni, EE. And this one for the A. Okay. Sebab tu ada darab 1, darab 1. Ini untuk yang EE, ini untuk yang AA. Okay. Okay, then sebab kita darab 1, sebab dia ada satu option dia macam ni. Okay, untuk soalan D, the consonant letters, the consonant letters G, M, T, S are together. Consonant lah, tahu kan? Kalau vowel tu yang A, E, I, O, U ni consonant. Yang G, M, T, S daripada huruf arrangements ni. Mesti duduk sekali. So, kalau dia duduk sekali, we consider it as 1 unit tadi. So, this is 1. 1 plus 8. The remaining 8 letters. Kenapa tinggal 8 letters? Sebab altogether you have 12. 12, you dah tolak dengan 4 this one. So, yang tinggal cuma 8. 8 letters. But then, untuk kira permutation, this one you consider as 1. Bukan kita consider sebagai 4. We just consider it as 1 unit. Sebab dia dah sit together. So, 1 plus 8, you have 9. Okay. 1 plus 8. That's why you get 9 over here. Divide by 2 factorial, 2 factorial, 2 factorial, and 2 factorial. This whole thing is the one yang repeated tu. A, R, E, dan juga N. Okay, the whole thing. And then you multiply with 4. 4 ni datangnya daripada mana? Datang daripada sini. GMTS. GMTS ni, you boleh arrange dia lagi in 4 factorial ways. Mungkin dia boleh duduk, G boleh duduk dekat ujung, S boleh duduk dekat depan, and so on so forth lah. So you just multiply it, this one. Okay. And the last one, the 2 letters N occupy both ends. Dua-dua huruf N yang kita ada dalam arrangements duduk dekat hujung. Satu dekat depan, satu dekat belakang. So, daripada 12 ni, 2 N kita dah guna, yang tinggal cuma 10 lagi yang dekat tengah. So, this N, this is for N, this is for N. This is for yang tengah tu. So, tengah tadi we have 10 letters. So, 10 factorial. Divide by, this one is for E, A, and R. That's why you have 2, 2, 2 factorial. Sebab berulang. Okay. So, you multiply lah. Jangan tinggalkan jawapan dalam macam ni. You kena tekan calculator. Masukkan dalam calculator so you get the answer. Okay. So, for the exercise, I leave it to you to try on your own.